Title of these notes is Standard Form. You need space underneath the equation. You're basically going to put the table underneath that equation. Okay, so you know you don't need very much space underneath that equation. So first thing, as a matter of fact, I'm moving that equation around. Okay. The first thing is that we're going to use standard form. This is standard form over here. I copied this from your notes the other day, that when you did the vocabulary and formulas. Okay, you got this equation then. So I'm going to put today's problem right next to the standard form of a quadratic. Okay. All right, so A is the number in front of x squared. B is the number in front of x. And C is the constant term. Okay? A number can either be variable or constant. So if there's an x in the term, okay, you know that you can plug any number you want in for x. So it varies, all right? Each term that has an x in it is a variable term. The one that has no x, we call it a constant term. It doesn't change, it's constant. This term over here will always be 7. Doesn't matter what x is, that term will always be 7. Okay? What is the value of A for this problem? 1. Okay, that's the number in front of x squared, if any of you weren't sure where that came from. What is the value of B for this problem? Negative 4. Very nice. Remember to take the sign of the number. So since this is negative, we carry that when we name the term. What's the value of C for this problem? 7. All right, so now what we're going to do is we're going to calculate the x-coordinate of the vertex. Okay, so here's this formula. All right, again, that is already in your notes from vocabulary and formulas from yesterday. Okay, but you can write it down again. X equals negative b over 2a. This way, when you're looking at your notes, you're going to say, where did that come from? It comes from that formula. And we're going to now plug a and b into this formula. So we've got x equals, now this negative is coming down. Okay? And then we're plugging in b. All right? So b is negative 4. So I have the negative and the negative. One negative from the formula, one negative from the value of the number. Over 2 times a. Alright, so the negative becomes positive. 2 times 1 is 2. 4 divided by 2 is 2. That is the x-coordinate of the vertex. Okay? We're going to put that as the first x in my table. That is also the equation of the line of symmetry. Okay? So the line of symmetry is a vertical line. In this case, it goes through x equals 2. So if we find 2 on the x-axis and draw a dotted vertical line, that's where our axis of symmetry is. Okay, that's important in the graph. It's not part of the parabola, but it's important. So do your dotted vertical line at x equals 2. All right, now we're going to take that x-coordinate, we're going to plug it into our equation. So I'm going to take this problem, there it is, and I'm going to plug in 2. Okay? So I have y equals 2 squared minus 4 times 2 plus 7. And then I'm using my laws of order of operations. So the first thing that comes is exponents. 2 squared is 4. Next, I'm going to do the multiplication, bringing down the 4. And then negative 4 times 2 is negative 8. And then plus 7. And then finally, I can do my addition. 4 minus 8 is negative 4. Negative 4 plus 7 is 3. So when x is 2, y is 3. All right, I'm plugging that 3 into my table. All right, so when x is 2, y is 3. Let's plot that point. 2, 3. Now, your teacher requires 5 points. The vertex is the first one. We need 4 more. Okay? Now, to do that, you are going to pick a number close to the vertex. So can you tell me a number that's close to 2? 1. So the next number I'm going to use is 1. Let's plug a 1 into that equation. So here's the equation. Alright, we're going to plug in 1. So y equals 1 to the second minus 4 times 1 plus 7. And again, use your order of operations. So 1 squared is 1. And then you can multiply. So negative 4 times 1 is negative 4. And then you can add. So 1 plus negative 4 is negative 3. Negative 3 plus 7 is positive 4. So when x is 1, y is 4. Let's put that in the table.
Can you just keep going?
No, I'm going to show you some shortcuts. Let's plot 1, 4.
Are we going to type these out?
Yes. Okay, so now I'm going to show you a shortcut, and I'm also going to talk to you about the symmetry of the parabola. Okay, so every point on this parabola has a reflection on the other side of the axis of symmetry. Okay, so instead of doing more calculations, I'm going to use a geometry property to find my next point. Okay, so this point is 1 block away from the axis of symmetry. Its reflection is also 1 block away from the axis of symmetry, but on the other side. So there's another point that lies on the parabola that's right there. What are the coordinates of that point? 3, 4. Good. Put that in the table. So by using properties from geometry, you can skip some calculations. Okay? So I'm doing this for a couple of reasons. 1, because I want to save you time. And number 2, because I want to see that you understand the properties of symmetry in this parabola. So these are the procedures I want you to follow when you graph them. Again, your teacher requires 5 points. So what we're going to do next is we're going to come up with 1 more point and then its reflections. So I need an x-coordinate that is close to 2, 1, and 3. Can you pick a number that's close to 2, 1, and 3? What number's next to 2, 1, and 3? 4. You guys are smart. So I'm going to do 4 next. Let's plug 4 in. All right, so I'm plugging 4 in. Do you have a question? You can ask a question. 4 squared is 16. Now I'm going to do the multiply. Negative 4 times 4 is negative 16. (16) plus negative 16 is 0. 0 plus 7 is 7. All right, let's put 0, 7 in the table. Oh, no, not 0, 7, 4, 7. Mrs. Paterno misspoke. We plugged in a 4. So we're going to put 4, 7 in the table. Let's plot 4, 7. So this point is 2 away from the axis of symmetry. What other point is 2 away from the axis of symmetry on the other side? 0, 7. Very nice, right there. So now you have your 5 points that your teacher requires. All right, so let's connect them to make a parabola. It's a smooth curve, remember, it's not pointy, it's not straight lines. That's how you graph a parabola, okay? Let me talk about a few things before I let this problem go. All right, I'm going to go back to this screen. No, that's not it. I'm going to go back to this screen, okay? You wrote this in your notes already. We talked about standard form a little bit, all right? Let's talk about if A is greater than 0, then the parabola is concave up. If A is less than 0, then the parabola is concave down. Okay? What is A for this problem? 1. Is 1 greater than 0 or less than 0? Greater than 0. That means the parabola is concave up. Okay? Again, one more thing. Any number greater than 0 is positive. Okay, so another way to say the same thing is that if the A is positive, the parabola is concave up. If the A is negative, the parabola is concave down. And now, I'm going to tell you an easy way to remember that. Okay? If I am positive, I am smiling, right? My smile is concave up. Okay? So if I am positive, I'm making a happy face. If I am negative, I'm frowning, right? I'm making a sad face. So that's a really easy way to remember. If A is positive, smile. If A is negative, frown. I'm going to talk about wider and skinnier when I do a different problem. We already talked about the vertex. The axis of symmetry we already talked. Okay, y-intercept is C. What was C for this problem? 7. Let's take a look at the graph. The graph has the point 0, 7 in it. So another shortcut that I did not use in this problem is I could have just done 0, 7, okay, without any calculations whatsoever, okay, because 0C is always the y-intercept, okay, and then we could have done its reflection. All right, I'm going to end the video on this one.